Hi, my name is Paul Glazer. Today I'm going to talk to you about a vision for AI-augmented simulation. The framing question is simple. What if your simulation could explain itself? Not just to produce a Gantt chart or an output table, but actually answer the question in a language your business already speaks. That's the shift I want to walk you through today. I'll lay out 4 pillars where AI is already reducing effort in Simio work, with live demos of both our desktop and portal MCPs along the way. By the end, you should see concrete places to apply this to your own models. Before we dive in, a quick introduction. I'm the Vice President of Consulting Services at Simio, and I lead a team of engineers who help our customers turn Simio models into scalable decision tools. I've been building simulation models for over 10 years, both as a consultant and as a business user. My background is in operations and supply chain, and I've worked across industries including chemical, automotive, and insurance. In those roles, I've covered everything from engineering to strategic planning. As a fun fact, my journey began as a Simio customer. I evaluated several platforms and chose Simio over some well-known competitors. Now let's talk about where simulation is heading and how AI is going to help us improve. Picture the everyday reality. A planner is staring at a Gantt chart. Orders are slipping. The natural questions are, why are these orders late? And can I change that outcome? Today, answering that takes pivoting across multiple charts, digging into resource details. Sometimes that can be hours of work, and most planners don't have those hours. The premise of the rest of this talk is simple. What if the model could just answer the question? Not generate a chart or let the user puzzle it out, actually return the answer and the data and the logic already in the model. That's the shift we'll spend the rest of the time here exploring. So I'm going to take a live look here in a moment about the Simio Portal MCP and how this will work. But let's ask it the question of the planner. Which orders are late and what resource is causing it? Behind the scenes, Claude is working with the Portal's MCP. As you'll see here, it creates the run, signals when it's complete, and then takes the user's question for an answer. From there, Claude interrogates the data, identifies which orders are late, joins it with resource utilization, and ranks the late orders, and surfaces a pacing constraint. It even can create charts and provide insights on why those orders are late and suggest alternatives. The Portal MCP is powerful because the users just ask in natural language and they don't need to navigate the underlying model or learn how to use Simio on the platform. Business stakeholders get answers from Simio directly, and that's how we expect users to interact with Simio in production going forward. In this example, I'm using Claude Desktop along with Opus 4.7 and Simio Portal MCP. For this example, I'm going to start to talk to the Simio Portal as a planner would, and we're going to create a plan and do that just through natural language. So here in the first prompt, you'll notice that I've instructed it to use the MCP, connect and create a new plan called today from our discrete part production, which is the example model that ships with Simio, and then we'll review the results. From here, Claude interacts with the MCP, authenticates, finds the model, creates a plan, runs it, and then checks and sees that it's complete. From there, it already starts with a question. It says, do you want to review that model plan from today? And do you want to see on-time and delivery and performance? So I said yes. It goes and pulls the data for that. And then now it starts to, in natural language, explain how many orders are on time. So 19 of our 27 orders were on time. 8 of those orders were late. And it creates these nice charts to help illustrate for the planner what's happening and what the issues are. It then goes on to give us a quick synopsis of what could be wrong with the orders that are late. So notice there's a pattern with them, that it's material C, and it has some aggressive due dates. And then it suggests a few things for it to check. From there, it continues to suggest things that we could further interact with the model and learn about. Simio plus AI is what makes this all possible. It's a shift from static models to conversational systems. And I think we'll all need to start thinking about this new paradigm. There are 4 places we're already using AI to improve Simio and our customers' use of Simio. First, talking to your model. We think the interface itself is going to change, powered by MCPs. Once a model is set, it can be queried in natural language and the workflow becomes much simpler. Second, debugging and design. AI can catch bugs, helps sketch out logic, and helps us build better, more robust models faster. Think of it as a second pair of eyes in every model. Third, documentation and understanding. AI makes it possible to grasp models that you're unfamiliar with, and to generate documentation in natural language as a byproduct of the work instead of a separate project. Fourth, the pipeline. ETL, data validation, and process logic as code. The integration layer in the front of and around the model becomes something you and the AI can read, modify, and extend together. So let's talk for a minute about what this shift unlocks. Engineers spend more time engineering, less time on plumbing and boilerplate, and more time improving operations. The simulations themselves get more robust. There's ETL testing, and the outputs are higher quality, and users can actually get what they want from the model. A new audience unlocks. People who weren't going to learn the tool can now engage with simulation because it's easier to work with. We lower the bar and get results from simulation models faster and better than ever before. And critically, the value comes from business users extracting insights directly. The engineer comes out of the loop as the intermediary between the model and the business. They move up the value chain to building the model itself. Pillar 1, talking to your model. This is the foundation. The interface layer is going to be powered by MCPs and everything else builds on top of it. Once the model is set up, it can be queried in natural language. Instead of building dashboards and tables to surface every possible answer up front, you let the user ask their questions in their own words, and the AI works with the model to bring back the answer. The workflow becomes much simpler and much more useful for the people who actually consume the model's outputs. Today we're getting value from a simulation usually looks like this. The engineer integrates the data, builds a custom dashboard, populates tables, then iterates many times alongside the business user until the dashboards are useful. Every new question is another build cycle. The more efficient way, the engineer builds the model and an AI layer lets the stakeholder engage with it on their terms. Natural language in, structured answers and charts out the other side. Through this shift, the engineer moves up the value chain. Their job is the model, the high fidelity logic that gives real answers, not the dashboards on top of it. Business users get to ask questions directly without waiting on the engineer to produce a new visualization for every question that comes up. They get answers in seconds in their own language, grounded in an actual working model. Two key enablers that make this work. The first is skills. Skills are discrete, callable actions an AI agent can take. It can run an experiment, query a KPI, or repeat tasks that you do frequently. One of the first skills I built makes our Python step inside Simio easier. There were a few things I had to repeat on the AI every time, so I packaged them up. Now I can drag and drop this skill into a new chat window or use it in VS Code with Claude Code. Once a skill is built, it can be reused across any AI model or interface that supports skills. The second enabler is MCP, the Model Context Protocol. It's an open standard that connects AI models to external tools and data sources. It operates as an interface layer between the LLM and an application. In our case, between whatever LLM you choose and your simulation model. The AI asks questions and receives results in a planned, structured way instead of one-off custom integrations. The way I like to think about it is ingredients and recipes. You give the MCP your APIs as ingredients. You write simple recipes that tell a little bit about what users typically ask for and how to bring the answers back. The MCP uses those to interpret the questions, fetch what's needed, and return it. Let's dive a little bit more into the MCP. This is a common language that AI uses to talk to applications. Through an MCP, you get three capabilities. Read, the AI queries the application's data. Act, the AI takes actions like running scenarios or modifying tables. And compose, the AI chains those activities together and to answer multiple step questions. This is an open standard, and adoption is going to become the norm. If you haven't seen MCPs popping up already, after this talk, start watching for them. Anytime there's an AI news story or a product announcement, MCP is showing up right after that. It's becoming the default way AI integrates with applications, and Simio will be part of that. In the Simio context, there are going to be two MCPs, one for each moment in the model's lifecycle. The first is Simio Desktop MCP. This is the development MCP. It can read and act on the model as you're building it, look at tables, walk through process logic, inspect events, and help you understand and work on your model directly. The second is the Simio Portal MCP. This is the production and operations MCP. It reads deployed models, gets answers for business users, and turns those into actionable results. Exactly what we showed in the portal demo earlier. Both are MCPs that are used in very different ways for different audiences. Together, they support faster model development on one side and easier use on the other. The Simio desktop MCP will be helpful because it will allow modelers to ask questions of the model. You can ask, what does this process do? Are there any of my routings pointing to entities that don't exist? Is there a setup time column in the resources table? I'm going to show you now a quick example of how this could work in Simio. Okay, for this example, I'm going to demonstrate what the feature could look like of AI and a Simio desktop MCP could look like for you. So on my screen, I'm showing the scheduling discrete part production, but it has been broken by our support team to introduce a couple of errors. And I'm going to show you how the add-in would work. So at the top, we have the Simio Oracle add-in. And for brevity, I'm going to pull in a conversation that's already happened. So this particular add-in can reference either Claude or a local Olama client. And then using different skills, you can pass information into the AI to give you answers. So in this case, I've supplied the documentation report from the model. I took a copy of the error that was displayed and told it to use the MCP to check the data. So after a few minutes, it came back and said it has everything to complete this analysis. And it found the root cause, which is the correct root cause, which is the auto set table row references were not set correctly in this model. It then suggests how to do it, including a step-by-step guide on how to do that. There's some secondary risks that it highlights, which the modeler could go through. I've asked it if it can fix it for me. In this case, it doesn't have access to those API endpoints to solve it, so it again reiterates to the user what to do. So I tested another example and said, turn the color of the server cut1 to show red. It did that. So just as a live example, we can say, what is the 7th row in the resources table? And in the background, the MCP is going to query that table, and then it will return to us a value. And so here's the 7th row in that table. It's weld, etc., etc. And we'll just confirm that over here. Indeed, that is the 7th row in the data. So as you can see here, being able to use natural language will introduce a whole new level of interacting with Simio Desktop. AI is excellent at understanding and explaining logic. So when you get here, make sure you challenge it. Ask follow-up questions, make it justify what it's telling you. On to the next pillar. Pillar 2, debugging and design. I like to think about this as a second pair of eyes on the model logic. AI doesn't replace your judgment, but it catches things you miss. Silent failures, wrong references, edge cases you didn't think to check. And it does so systematically and programmatically every time you ask it to. Here's a real example. We gave an LLM the model documentation generated on the ribbon, plus a systems thinking template, and we put it on a warehouse AMR model. It found things the human had missed. There were some missed shipments that were silently being excluded from one of the KPIs. A load speed formula was referencing an unloaded value by accident. Charger fallback sent every vehicle to station 1 under stress, which wasn't the desired behavior. And there was a dual inventory tracking the system that silently diverged. AI can go through and check for these systematically and programmatically. Think about the times you've had a model frustratingly not working and the bug turned out to be something simple, an incorrect reference, a silent feature. I think this is going to be a game changer on how much time you spend reviewing and fixing your models. In the long term, I think this will also make us better modelers. It pulls us towards Git and other software engineering mindsets. It pushes us towards logic that doesn't fail silently, towards better architectures, and towards models that other people, including AI, can read and reason with. Specifications are a place where projects bog down. Here's another AI workflow that I think you'll find very interesting and helpful. You interview your internal and external stakeholders before building a model. You work through the requirements and gather everything you normally gather. Then you take your notes and your call transcripts from Teams or whatever application you use, and you feed those into AI. Along with that, you give it your spec format. You tell it the terms you want to use, the structure, and the level of detail. The AI generates a functional requirement specification that's ready to build the model from. Because it's natural language, you can work with your stakeholder directly and confirm they agree with your inputs and outputs of the model, how it will be built, and other design characteristics. Once you align on this design, you can do that before you even write a process. Then as a modeler, you go in and you build it. You spend a lot less time grinding out Word documents and a lot more time getting into modeling and value creation. The spec stops being a bottleneck. Another opportunity is writing Python steps from a simple prompt. As you know, we recently released Python as an import and export feature and a Python step that you can use for coding during runtime. Specifically here, I'm thinking about using a Python step inside of Simio to do something we'd previously have built with process logic. You can now go into an AI tool, explain the type of logic you need, and have it build that step for you in Python. The AI writes the code block, you paste it in, or you use a Python skill directly in VS Code inside of Simio. This is a paradigm shift. There are going to be times now where it's faster to write a Python step than build out a piece of Simio process logic. There are also things that Simio does best, and there are things that Python does best. I think combining those will take advantage of their respective strengths in a way that other applications can't match. Pillar 3, documentation and understanding. I think this is really important for making models that users can actually use and update going forward, both business users and other modelers. A model that can't be understood is a model that quietly dies after the engineer who built it moves on. AI can change that equation. Auto-generating documentation. Everyone agrees a model should have current documentation, but no one has the time to write or maintain it. So documentation goes stale, or in many cases they never exist at all. The fix here is to point an LLM at the model through desktop MCP or using VS Code with something like Claude Code or Codex inside of it. The LLM walks through all the logic and documents in a natural readable form, Word, Markdown, HTML, whatever your customer wants. Now, obviously, be careful here. Don't put data or logic that's sensitive into a public AI. Look through your particular model's documentation before you share it. If you work for a company that has its own internal AI system, that's great, use it. But at the end of the day, this means documentation becomes a byproduct of the work, not a project in itself. It stays current because the regeneration is cheap, and the engineer stays focused on the value added work, not on writing a document that no one updates. I'm sure this is a familiar situation for many of you. You get a model that was built by someone else, it lands on your desk, there's a problem, and you've been asked to fix it. Now imagine being able to ask an AI to explain the model to you at a high level, walk you through the main process flow, point out where the assumptions are most likely to break, and help you debug it. Suddenly, onboarding with an unfamiliar model goes from an hours or days long task to a quick workflow where you at least understand the framework that's there and start to work with it. We also think this helps multi-modeler workflows. Where there's multiple users working with the same model, the AI can help everyone understand it more quickly and make changes together as a group instead of stepping on each other. Pillar 4, the data pipeline. We're going to talk about ETL, data validation, process logic as code. The integration layer that surrounds your model is just as important as the model itself, and AI changes how you build and maintain it. Every complex Simio integration has an ETL layer. The decision isn't whether you have to build one, it's in what language and where it's built. Pure Python plus Pandas is a language AI already speaks fluently. AI can read it, explain it, and modify it quickly. That matters a lot when you think about pipelines and bringing data into Simio. Practically, that means that you can pull up your AI, ChatGPT, Claude, Gemini, whatever you use, explain the data sources, how you want to join them together, what filtering you want to have applied, and ultimately what tables you want to be produced. You don't have to involve other vendors. You don't have to involve other individuals. You can build the entire pipeline inside of Simio as you go. It also stays clean architecturally. The Python importers and exporters are all inside of Simio. You upload one file to Portal and you've got a full ETL and the model in one easy-to-use file. And the bigger shift, new business rules become a conversation, not a vendor engagement. The user can describe what they want, the AI extends the pipeline, and you ship. It's also important to think about the advantages AI brings to data validation. If you've ever dealt with production data, you know that it's always messy. There need to be checks run before the model runs. I strongly encourage you to start using Python importers to do data validation up front. This will save you a lot of time in running and breaking models when the real issue turns out to be in the input data. There are 4 general tiers of checks I suggest most modelers run. First, schema and key integrity. Make sure your keys and your foreign key relationships are intact and the data is in the shape you expect. Second, look for silent failures. Things like products without routings or bills of materials, zero efficiencies, or other things that will bog down your model. Anything you can check logically, tell the AI what to check and where, and it can do the rest. Third, supply and demand feasibility. Think about a rough cut capacity check on your supply chain model. You can do that up front in Python and make sure your inputs are roughly in the right ballpark. Fourth, whip and release conditions. Make sure your release rules and in process inventory rules are working before you turn the simulation loose. AI can help you write these checks and the validation around them much faster than writing them in Excel or some other tool. And then you can run them every time the model runs. One more suggestion: write your check results into data tables as well. That way you can fail out gracefully if there's a serious data issue. During run initialization, check that table with your responses and tell the model whether or not it's safe to run. If not, display the issue on a dashboard so the user can fix the data for you. So those are the 4 pillars, and together I think they'll make a big shift in how we build and use simulation. First, talking to your model, both as a developer and a business user. The interface becomes natural language, and Simio is something stakeholders engage with directly. Second, design and debugging. AI is that second pair of eyes that catches bugs you'd miss and pushes you toward a better, more robust model. Third, documentation and understanding. Being able to grasp models more quickly, generate documentation as a byproduct, and have models that live for a long time because the next person can pick them up. The fourth, the pipeline. Using AI to create ETLs so you can avoid intermediate applications, validate your data, and start making process logic as code when it makes sense. Together, these change the kinds of problems Simio can solve and the people who can engage with it.
Hey, Paul. Thanks. Can you hear
Hey,
me
Adam.
okay?
Yeah, good. Same here.
Great. Well, thanks, Paul. Full disclosure for the audience, Paul is my boss, so I'm obligated to say that that was a great talk. Um, but we've spent a lot of time collaborating on the Simio AI integration story, so I've seen a lot of this firsthand, and there's plenty to dig into. So let's open it up to some questions.
All right, sounds good.
Great. First question from the audience: for the AI chat, does it run locally or does it have to communicate to outside servers?
Yeah, good question. So right now, that's really just kind of a prototype that we're working through internally. It can do either one. So I can do a local instance of open source model. So for that one, I chose a Llama. My laptop has a NVIDIA card on it, so it is able to run a model locally and kind of keep everything within the laptop, or it goes outside to Claude. So I think in the future, it's going to be important to, as we go across different customers and different scenarios, allow them to operate with different models of varying levels and security.
Very good. Take the next question. Seems like folks are eager to get their hands on this and get started. So, are any MCPs included with the base license, or is the add-in required? Can you talk a little bit about what starting up might look like here?
Yeah. So again, right now everything's kind of in internal development, so we're really just trying to learn. I'm sure, as everybody knows, the space is really new and it's evolving very quickly. So nothing's really included in the product right now. The Oracle I showed is an add-in. Obviously, any of our users can use the add-ins and build those on their own. To do that, obviously, leveraged AI pretty heavily just to build the add-in itself, which helps. So kind of more to come on that side of things of when and how MCPs will be included in Simio, but something we're actively working on.
Great. Yeah, to follow on here, so I think you've provided some clarity on what is and what's not available, but um, the Python steps and the importers we have integrated in the product. So if you were an experienced modeler listening to this call, could you comment on what the highest leverage first step might be? Where would you start with what is available today?
Yeah, so Python steps for sure. Import, export. Presentation before this, Accenture did a nice job of explaining how to build out ETL pipelines, and AI is extremely helpful there. It's very good with Python, and you can tell it what your sources are, what you want your data tables to look like, and it can create those flows for you really nicely. I think as I mentioned a little bit, there's going to be Python steps that replace traditional Simio logic. The example I always go to is sorting a table alphabetically, right? Like that would be really painful in Simio logic, and that's kind of on one side of the spectrum of things that Python does well. There's a lot of things that Simio does well, and no need to reinvent the wheel. Um, but I think there's going to be an iterative journey for most of our users where they build something in Python as a step using AI, and maybe it does or it doesn't work. Maybe it's not as fast. Maybe it doesn't. It's not as good as Simio, or it could be better. So a lot of journey, I think, is going to happen here.
Great. Do you have a starter template or example Python importer available so we don't have to build the whole validation layer from scratch?
Yeah, good question. So I will have to double check on this. I can't remember if it is a Symbit or on our Git, but we do have a few examples of how to use Python as a part of the importer. So, really explains how to use it and work with it. Um, the short answer here is on the importer and exporter side, you're really kind of working outside of runtime, which is nice if you're familiar with Python or if you worked in it before. You don't really have to interact with Simio too much. You're just creating these CSV files. And I don't necessarily have a template or a thing to do on validation. What I will say is LLMs are really, really good at this. If you can explain your business rules or the logic rules of that data, it can do a nice job of it. What I've done in the past is really just given it the data schema. So if you've used Simio before and you can use that schema viewer button or any tool you have, it's just really good, right? It's already seen a lot of these patterns. It's going to do better than any template that we have and create a data validation part of the script as a part of the ETL. I think what's been a game changer here for us is at the end of that ETL process to essentially write out the status. It could be a one row table, right? It could be pass fail, it could be details. But now, as you import that into the model, being able to call that during the run initialization step and basically say, hey, do I have good data? And if yes, then run the model. If no, drop out now and tell the user so they can fix it.
Yeah, absolutely. I think creating some of that feedback, whether it's for a user experience of a business user or as the developer, investing in some scaffolding to give yourself feedback of what's happening is really valuable. Yeah, good question here. So, what types of questions do you think are handled well today? And I think even more broadly, kind of with LLMs related to Simio. And what types of questions do you see it struggle with?
Yeah. I think a little bit of my journey here a year ago, kind of started to play with ChatGPT and Gemini and some other ones. And I'm assuming a familiar experience, but it was kind of interesting, right? They answered some questions and they got really far off sometimes. The portal MCP itself is really just exposing our API endpoints and creating those recipes. Um, it's been a journey to just think about what does a user want to ask and how will they ask that question, and then what does that relate to in a workflow, right? So kind of version 0 definitely did not work very well. Got itself very confused and couldn't pull together data. Um, but at the end of each time, I would essentially spend some time working through the sessions, and then again, another thing AI is great at is it can summarize that conversation and tell you where it got lost and tell you what was confusing and continue to help update the skill files and the kind of the intermediates between the LLMs and the MCPs to a point that it now understands what a user means when it says a project or a model or a plan in terms of the really technical ones and zeros.
Yeah, great stuff. Okay, let's see. Architecture diagrams. So I want to expand this question a little bit. Thinking about the paradigm shift, do you think there's sort of a core architecture diagram or conceptual diagram that would apply if I was trying to sell this to the business? or do you see it more as sort of a custom, depending on the environment you're building in? How do you think about this sort of architecturally and broadly?
Yeah. So, and this is interesting, right? I mean, again, I'm going to feel like a broken record here, but new space, I think it changes every day. Um, I think that almost like APIs were, years ago, having an MCP is going to be a standard so that you can operate in the ecosystem, right? So Simio is going to have an MCP, different applications that we work with will, and then you'll have essentially one or two or six LLMs that sit in the middle, right? And they just need to know where that instruction set is, when to use that tool. So, I kind of see MCPs as another entity that's operating out there, right? So you have LLMs, and effectively the MCP sits in between the application, the LLM. But I think that's going to be a broad standard, not necessarily a Simio specific architecture.
Yep. Good. Our company does not allow the use of public LLs. Can we use our own LLM as long as it has MCP client support?
Yes. So again, that Olama client that's local. The one caveat here is you do have to have some sort of graphics card locally. I think it depends on what you're able to do as far as your hardware. Obviously, graphics cards and things like that play a large role here. What I'll say, kind of my experience so far, is basic NVIDIA graphics card on my laptop is able to run a pretty basic model. It is able to work and get answers, but it's not to the sophistication level that the public LLMs are. So again, I think it's going to be an evolving space. It would be great if that model can run locally and nothing has to leave your four walls. I think we'll get there eventually. But we kind of have to look to the edge to see what's possible and then pull back into what's really feasible.
Yeah, seems like some good opportunities to follow up and have more pointed discussions with some of our customers who are interested in this.
Yep.
Oh, this is a good one. I'm trying to outsource some of the heavy lifting here. What about using an LLM to build the model in the first place?
Yeah. So obviously, speed to value is something we care about. Our customers care about. I think this is an interesting question, and it's going to be possible, right? I do think you're going to be able to just talk and build a model. But something that's highlighted to me as I've kind of gone on the AI journey is just being able to jump in and build things fast actually isn't, it can be a bad thing in some scenarios, right? Where you just get in and you tell it to start building, you start building. And Adam, we've had this discussion here over the last couple of months. We've actually spent a lot of time now using AI as a part of our specification development workflow, right? So helping us generate questions to ask our stakeholders, helping us to think about the formatting of our documentation. Can you ask a model to build that out? Probably. I see it happening in VS Code. I see it other places. But I think it'll be a journey. I think you're always going to have the engineer in the loop. Like many other applications, I think you will still need to touch and click and do things and do testing. But I think we will get more and more here, and especially on tasks that are painful, right? As we look at our backlog and we see some of the things that we have out there that can make a modeler's life easier. A question now going around is, does AI quote unquote solve this, right? Do we just expose the MCP and let it replicate some process or do something for the user? So I think it'll be a journey, small steps to big steps, but it won't be. I don't think by the end of the year you'll just say make a model of a factory and it'll whip it up for you. Unfortunately.
Yeah. So as modelers, we retain some job security for now, which is good. And I'd like to just elaborate on that a little bit. In my experience, have really thought about the context provided and having that discussion. I think a lot of us have felt at times as a modeler, sometimes you end up on a bit of an island, as the owner and the developer. But keep an open mind about how you use it, because you can provide a trace file, you can provide documentation, you can provide processes is XML. If I copy a process out of a Simio model, it's XML under the hood. So, I've tried out a number of different things and had some success getting feedback from, a tool like Claude. So, a lot of exciting avenues in that regard to get support and, help yourself with your modeling. All right, let's see. Where does the AI model get the Simio learning from? Typically, if I ask AI about Simio, it does not know much about the inner workings of the software.
Yeah, this is a good question, and one we're debating actively, right? So, just in general, how AIs work, obviously they're trained on different data sets. My experience has been similar. There's definitely companies and models that don't really seem to know much at all about Simio. There's other ones that seem to have a pretty good grasp of Simio, but maybe not in the details of our documentations or our experts. Generally, what I've learned about the space, right, is you can tune or train or otherwise provide a model reference documentation through different databases or MCPs. So I think this is another space that as we get MCPs and things like that working, we may need to supplement that with some different technologies. I think it's RAG is what I've seen out there, but it's effectively where you can put information specifically for that model to reference. So instead of the MCP where it's interacting and doing things, think about this as more of a library of information. So being able to put our help files out there, our support files, our SIMBits, and then allowing essentially the AI to walk you through a SIMBit versus the PDF, right? Those are things that can happen as it gets more and more information. And then second to that, I think you have to constrain or otherwise tell that model, this is the source of truth. Don't make up things if it's not in here, and those will help us get to tighter answers.
Absolutely. Great. Next question. Yeah, so I think hearing about this paradigm shift is really a big statement from Simio. I mean, we've been branded as sort of no coding required for a very long time. Um, so can you comment on, when do you think Python versus process logic, what makes them distinct and where might one be better from the other?
Yeah, so I'll probably take this a step further, and I think about Simio's elements, right? So things like bills of materials, inventory, the things that are really baked in well. Those are going to be things that, for me, are always going to stay inside of Simio. Where I start to think more about Python is kind of the in between now, right? So definitely on the ETL side of I have various data sets. How can I synthesize those together and get them to match up more closely with ISA 95 or some template model I have? So in the past, I probably would have spent more time in process logic, recoding logic to match data as I received it. Now I'm thinking more about shaping data into the standard constructs of Simio. Once I get inside of Simio and there are things that I can't do, or looking at a Simio ability to do something versus Python, I'm really going to start to look again at long pieces of code, right? So in the past, we've done forecasting or other data work inside of Simio. Really looking to farm some of that out and just stay with the logic that should stay inside of Simio. Decisions on transfer nodes, things like that. Um, but yeah, I'm really curious here to see what our users do. Honestly, it's really just kind of crystal ball at this point and see what people do, and then I think that'll guide the community.
Yeah, in my experience, I think there's some gut feel for when a piece of process logic is going to be complex. Um, if you need sort of a dictionary or lookups or multiple searches, there are certain things that Python can do very well by sort of loading that data in and, returning something a little bit more comprehensive than doing it kind of one block at a time. But yeah, I agree. I'm excited to see where folks go with this. This is an exciting question. So, what role do you see for LLMs in synthetic data generation for simulations?
Yeah, I think it's going to be huge. This is one I haven't really had as much time to play with, but a question we get asked a lot, right? In the what if side of things, what if we do this? What if we do that? For simple systems and simple problems, right? We've always leveraged the controls and model properties, and experiments work great. But now, as systems get more complicated, questions get more complicated, um, you know, how can we leverage these models to change data sets that we have, right? So what I see being possible even today, right? I think the question earlier about, what could I do today on the Python importer? You could pass in parameters and model properties, right? So you could create a string model property, pass that into a Python importer step, and then basically tell it what to do, right? Add two routings to this table, do this to my base data. And in theory, it should be able to do it. I think the devil will be in the details, of course, but um, this is fantastic. It's also a great way to test your models. So outside of synthetic data, Adam, we've had some discussion about this of taking on more software development principles like unit testing and stress testing your model. So even offline of the model, being able to create data sets that represent edge cases or testing, they could just do it so quickly and with such limited instruction. It's going to be really powerful.
Yeah, I think over the past year or so, I've started to distinguish in my mind, kind of planning and scheduling applications. So from a planning standpoint, if you have a plant model or a supply chain model and you're interested in supply planning, capacity planning, demand planning, generate some data to create a ramp scenario for your demand, over the next couple of years or your horizon. Create a data set to introduce some supply variability or create capacity ramp scenarios. I think there's a lot of power here to leverage creating data sets to drive scenario evaluation, in a really powerful way. Next question. All right. Seems related here. So, do you see it possible that AI looks through the results of a number of scenarios or replications and recommends a good order sequence for another run? So, sort of post-process kind of analyzing here.
Yeah, absolutely. I especially see this on Portal being really nice here. You go back a couple of years ago, we did a presentation with McKinsey about machine learning, and effectively it was kicking off runs and bringing those back and evaluating it. So definitely, kind of possible here. I do think this one is really interesting on the scheduling side of things. Of if a planner wants to create two or three different plans, in whatever way they want them to be different, being able to do that. And then, the MCP now allows us to query data across those, bring them back and compare them, down to the order level, right? And in the example that I showed there, you could see which 8 orders were late. It can figure out what's in common between those. So not only are LLMs going to help us get the best sequence out of multiple replications or scenarios, it's also going to really speak to the business user on why things are going on. The questions they've always asked us as modelers, we can get out of the loop of that a little bit and let the model start to explain what's happening.
Really good. Okay. What skills, callable actions, have proven most valuable in your work so far? Is there a pattern or some guidance for which actions are worth packaging as a skill versus prompting fresh each time?
Yeah, good question. So I've got, I'll say my top two that I go to. One is for Python steps inside Simio. So created a skill for that. Shared it here with the team. I know Adam, you're smiling a bit. It's a game changer when you can pop open VS Code and drop in the skill and tell it what step you want to have built. Especially if you know the context of your model, what you're passing in and what you're not. You're talking about coding up a custom step in a matter of 10, 15 minutes on the shorter side of things. The other one that I've used quite a bit is what I call a model understander skill. So being able to take the documentation report outside of a model, strip out all the data, and just generally understand what that model is built on, right? What is it doing? And then very quickly identifying when process logic loops are conflicting with each other. And Adam, we've worked on this one in particular together, but this will probably resonate with a lot of modelers where you've gotten in, you're building a model, and adjustments and changes happen, and it's difficult to know where your logic loops and your data and your Simio elements might be in conflict, and it takes a long time to run those things down. But it's pretty simple to see when the LLM looks at the documentation report and sees the same references. I think I mentioned too in my talk about finding hidden bugs, right? We had a demo model we had built here, and we've been demoing it for quite a while. And we realized, oh, we referenced a incorrectly named field that was very close to another one, and we just wouldn't have picked up on that, right? But it kind of it failed silently, and really really good at picking those types of errors up.
Yeah, I would agree and echo with the scripted steps. For those to whom this is a new concept, there's some syntax in Python for things like getting a property value or interacting with a Simio table. So consolidating that into a skill file, sort of all the need to know syntax information, and handing that to the tool is really good to package. And also something like how to filter and interpret a trace file. So when you run your model, you get a trace output as a CSV that can be very large. So providing context as to how the tool might parse through that and filter. But if you think about it, I mean, that gives you your full model execution. So you see processes and the ordering and sort of every transaction there in the model. So I've had some success interacting in that way too.
Yeah, and maybe I didn't want to miss the second part of that last question, but kind of when in my pattern for that, right, is um, if it's something that I'm going to repeat, and the industrial engineer side of the head here is, I'd like to simplify that, and how I've built all of them is I just at the end of a task where I've done something, I just ask the model itself to create that skill. It looks back through the chat what it did well, and you can iterate with them. So when we talk about the skills, the really cool part is they're built by the models, right? It kind of packages up what you worked on and saves it for later. So they're pretty low effort, high return once you start to build skills.
Right. This is great. For someone whose model keeps breaking on bad input data, where should they start? Is there a tier in the framework that gives the highest return for the least effort? As we know, it's often not as simple as just fix the data. But Paul, hearing some of your thought process about this, I think would be really valuable. So what do you think?
Yeah. Again, this question is interesting because again, 6 months ago, I probably would have answered it differently than I do today. But as far as where I start now is definitely key relationships, and understanding, anything that could be broken across tables, things like that. Where I've gotten to is really putting that schema in, and my prompt starts something on the level of I have a data schema, and I explain a little bit about what it is and give it some context on that. And again, no data has to come in at this point. It's actually best if you don't. But you explain what that data is, kind of row by row, and there's different ways to do that. And then allow the LLM to create those data validation rules and create the checks and do all that for you. As far as tiers go here, probably my biggest recommendation that I've learned over the last couple of years is shrink your data set. So the first thing we start to do now is, we get production data, we shrink it down to one product. We make sure that works through. Then we go to a family, and then we go to a group of things. So it's very easy to start to scale that up, and then you see when it breaks, and then whatever that rule is, you just go back and you can keep that chat going. Really what I've gotten into is creating repositories for my data validation. And then we keep a change log and we keep it going, and you build it over time. So um, I think that's a little bit of a meandering answer, but definitely start with the simplest things that are breaking you can import in data, and then work into your more complex ones, and leverage LLMs to think of the things you don't think of. They're really good at that.
Yeah, I would reiterate what I think we said a couple times or alluded to is that using the tool to help inform it as you go along. I've improved at, instead of just getting into a chat and sort of plowing through in a linear fashion, asking it to generate a change log or a handoff document or some context that I can provide back to it later has been tremendously valuable. So sort of having it document your work as you go along with it, good or best practice for sure. Little more time, a few more questions, so we'll keep rolling here. For multi-modeler teams working on the same model, what practices work well for collaboration? Has AI changed how you think about model organization, naming conventions, or breaking models into pieces?
Yeah, so probably I'll start with things that we do differently now, kind of where we're changing and where I see it going. As far as the now, really started to look at documenting our models better. Something we haven't done a great job of in the past. We document inside of Simio, but as soon as you want to turn that model over, you walk away from it for a while and come back. One of the very first things I did was take the documentation report itself and just generate a Word document. So very simply, you put the HTML into the chat and say, turn this into a Word document that explains it. Over time, we've built skills to do that better. And you just you look at that report, and then sometimes it starts to help you think about naming and other things. You can have it make suggestions. It's helped me learn and understand the importance of Git in the last few months in particular. Noticing and hearing the question, right, naming conventions. That's something we've held on to for a long time. That always feels like the way Word and Excel used to work, where you had to save off 6 files, and now with Office, 365, it just saves them in the background, and you can pull back. I think this is where model naming and conventions and things are headed. We're going to see more READMEs, we're going to see repos, we're going to see change logs, and the model name itself is not going to change anymore. You're going to be able to know what revision you're on, what the changes have been, unit testing, things like that. So now multi-modeler teams for me are going to change, where it may not be 3 or 4 people working in process logic in Simio, but it could be somebody who's working on the ETL and the Python steps, somebody's working on dashboards, somebody's working on documentation, and all that's centered around a Git repo. And at any point, you can do a build, right? Just like you do with other software. So I think that's going to come and change roles and who interacts and how the models get built.
Innovative stuff. I think we're getting close here. 1 or 2 more questions. What has the change management story with this new paradigm been like? Maybe you have specific, or you could allude to some customer examples, but how do you build trust that the AI's answer is correct and that this is a good, way to go as a modeling organization or for a project?
Yeah. So to full transparency here, right? We don't have anything that we showed here in production with customers. This is kind of what we envision and where we think things are going. I think we still have things to learn about this in particular, right? So how do you have the model only return what it knows? How do you limit hallucinations? But it's been interesting in both professional and personal as you talk to different people and their interactions with AI. I think there's a level of knowledge that I can't trust everything that this tells me, and there are different ways you can surface information to build trust or build questions, and these are just going to be skills that everyone has to learn. But I look at really what the problem statement is here, right? Sometimes simulations are too difficult for our non-technical and our business users, and allowing them to interact more directly with the model is going to build a ton of trust, even if it's not right 100% of the time, right? Even if it's 80% right, and they're getting the answers and they're building confidence and trust in your tool, it seems like it's worth it to me.
Yeah, it's really exciting that we're all sort of learning together here. And this has been a fascinating topic to me, and to see where we are in a year or two at Simio Sync, continuing this discussion will be really neat.
Yeah, I hope we have some actionable stories. So that'd be cool.
Very good. And we will wrap with this question. Can this video be downloaded for later? Paul, just go ahead and comment on that. So the answer is yes. Everything will be released on our website on Thursday. So certainly you can refer back to these presentations. That's all the time we have. Paul, thank you so much. Thanks everyone for tuning in.
Good chat.